All right, hi students, welcome back to a new video on differentiation techniques, part 2.2, all right? So today we will be doing on quotient rule, okay? Quotient rule. So what is quotient rule? As I briefly explained in the previous video already, quotient rule is basically when you have two families, when you have y equals to family of x dividing with another family of x, then you use quotient rule, okay? When you use, this is quotient rule basically. What about product rule, which we did in the previous video? Product rule, when you have two families of x, they're multiplying each other. But now it's quotient rule. Quotient rule basically means you have two families of x dividing each other. Okay, so you have to make sure. And the formula is this thing. The formula I won't go through with you, okay? I would just go through the steps with you. You try to understand first. Remember what is the steps for product rule? Product rule is basically you copy the first, differentiate the second, plus copy the second, differentiate the first. That is product rule. Okay. Okay. Or you want to use the formula, you can also lah. U times dv dx, basically you fix the first, differentiate the second, plus v, basically is the second one, du dx. All right, I want to erase everything here already because it's getting ugly already. I assume you've taken notes where you need to. All right, two families multiplying, I can leave it there. Okay, so actually, if you want to use formula base, right, y equals to uv, you can also. The formula is actually basically fix the first, differentiate the second, plus fix the second, differentiate the first. This is actually product rule. It's a recap for last lesson, okay? All right, so for today's video, right, we will be doing on quotient rule when you have y equals to u divided by v. U is a function of x. Basically, each of them is a family of x. Okay, when you have a family of x dividing with a family of x, what you do is dy dx is equals to v is you copy the second one, then you times the differentiate the first one, v du dx minus u dv dx. Then you got to divide with something, which is your v squared. This is the new formula. Basically, what it means, right? If you have two families of x, right? When you have two families of x dividing each other, when you have y equals two families of x dividing each other, what you do is, right, this one, this two, okay? I just label 1 and 2 lah. So when you differentiate dy dx, what you get is you copy the number 2, then you copy number 2, then you differentiate. Differentiate means I put d1 lah. Okay, you copy the 2, then you differentiate first one, then you got to minus, you copy number 1, then you differentiate the second one, d2. Okay, then what you do is you divide with v squared. V is the bottom one, which is divide with 2 squared. 2 basically means it's the bottom part, right? It doesn't mean 2. So once you have gotten this is actually the formula. So to get used to the formula, you've got to practice more. So we shall move to some practice questions. I'll do the circled questions as usual. Okay, you see this question now. This question you can actually use quotient rule. But I won't use quotient rule, okay? So I won't discuss this question first. I'll discuss this question after I discuss question number 2. Okay, number 2. I discuss question number 2 first. So you don't be scared if they give you d dx of something. It's basically same thing as when you have y equals to 3 minus 2x, 3x minus 2 over 4x squared. Find dy dx. It's the same type of question. It's exactly the same. They just write it in a different way. This is another way to ask you. This is actually another way they ask you differentiate. This is called differentiate. What's on inside the bracket? d dx. You don't see a y here. You don't see a y here because actually the y is this thing. But you don't have to really understand that yet first now. Okay, when you see d dx of something, what it means is that they want you to differentiate here inside this thing. Okay, it's like giving a command. Differentiate what is beside me. It's like a command. Okay, if other questions like, okay, let's see the first question. They give you fx equals to this one, then they will give you a command. Okay, find f prime x. They give you a command, but the command is find f prime x. But for this question, what happened? What happened? The notes went missing. The notes went missing. Okay, yeah, back here. Okay, but as I said, where was I? The command is actually find f prime x. But for this question, the command is actually given in this form. They give you ddx of this one, means they ask you to find what is the difference. They're basically giving you a command, differentiate what is next to me in the bracket. Basically differentiate this whole thing. Okay, it's the same thing basically. So what you have to write is you just have to write equal and give the answer. You don't have to write dy dx equals to. You don't have to. You just write equal straight away. Can really. ddx of this one is equals to what? You just differentiate whatever inside. So you can see it's actually a family of x dividing a family of x. Okay, so maybe if you want to, you can expand the top first. You can expand the top first. Once you expand the top, maybe it's easier to differentiate later. Once you expand the top, what you get is you get 9x. Okay. Wait. No. What am I saying? When you expand the top, this one multiply by this one multiply by this one, then this one multiply by this one multiply by this one. What I'll get is first one is I'll get 9x, correct? Then minus 6, then after that minus 6x plus 4x. Minus 6x squared. This 6x squared, yeah, correct. So what I'll get the top is minus 6x squared, 9x plus 4x gives 13x, then minus 6. I'm not sure whether if I calculated it correctly. Wait, yeah, I don't know whether I calculated it correctly. Yeah, I think it's correct. Is it? Yeah, it's correct. I think it's correct. This thing is correct. So I rewrite it first. I don't want to differentiate first. I rewrite it first. So when I rewrite, I need to put the ddx also because I haven't differentiated. So the command still exists. So I rewrite it as minus 6x squared plus 13x. I forgot the x here. Oh my god. Plus 13x minus 6 divided 4x squared. Okay, actually for this one, right, I can actually differentiate using, what I do, right, one method is I can actually separate each term basically become, you separate each term, become this one plus this one plus this one, then you differentiate using the power rule one by one. Use power rule. Okay, use power rule and you differentiate. But I want to use the quotient rule now. So how do I use quotient rule? Is basically, what is the formula? The formula when you have something like this is you fix the bottom is 4x squared. Start with the bottom. For this one, don't forget, start with the bottom, fix the bottom, basically copy the bottom, then differentiate the top. When you differentiate the top, what you get is you get minus 12x. Why minus 12x? Because 2 times negative 6 gives me negative 12. Then the power reduced by 1, so it's power of 1 here. Then plus 13. I don't want to explain why 13 already. I differentiate 13x gives me 13. Okay, so basically what I've done is I copied the bottom, I differentiate the top. Then I minus, don't forget, in quotient rule is a minus, in product rule is a plus, in quotient rule is a minus. Now I fix the top, I copy the top, minus 6x squared plus 13x minus 6. Then I differentiate the bottom. When I differentiate the bottom, what I get is, I get 8x. Why I get 8x? Because 2 bring forward times 4, I get 8. Then why is it x? Because power of 2 minus 1 gives me power of 1, which is 8. Don't forget, quotient rule, you have one last thing to do, which is dividing it with the bottom square. Bottom square is basically 4x squared in the bracket, square it. Okay, so I repeat now, what I did is copy the bottom, differentiate the top. Minus, copy the top, differentiate the bottom. Basically, you switch over the order. Copy the bottom, differentiate the top, minus, copy the top, differentiate the bottom. Minus, I don't forget minus. And then lastly is you square the bottom. Okay. Then you rearrange it. I just rearrange quickly. So I multiply inside, what I get is, I'll get, not enough space, that's the problem. I'll get minus 48x cubed plus 52x squared. I'll just multiply everything inside. Minus in a bracket, I just times 8x inside each one. Okay, this is minus 48x squared, x cubed, minus 48x cubed, plus 8x times 13x gives me 104x squared, then 8x times minus 6 gives me minus 48x divided with, how do I simplify this? This square power must go inside 4 and must times this one also, okay? So the number square, 4 square gives me 16. X squared, I squared basically x to the power of 4. Why is it so? Look at my indices video if you're not sure. So you continue to simplify with the cube, you can simplify, becomes negative because these two are like terms. Basically, these two are like terms. Why? Because they have the same unknown, which is x cubed. So I can plus or minus them, minus 96x cubed. Then look at x squared now. X squared, I have 104 plus 52 plus 156x squared. Oh, wrong. I haven't opened the bracket yet. Don't forget. So now I open the bracket, okay? I open this bracket basically. I missed out this bracket. So what happens when I open the bracket is minus 48. I copy everything first. Plus 52x squared. So minus gives me plus. Minus plus 48x cubed. Minus plus gives me minus 104x squared. Minus gives me plus. Plus what? 48x. Divided with 16x to the power of 4. So what I'll get is minus 48 plus 48, because they're exactly the same. Yeah, again, oh my god, why is it so messy now? Minus 48x cubed plus 48x cubed is something like taking, I give you 3 balls and I take 3 balls back from you, so you have none now. Okay, so what you will get is actually 0, right? So now we solve for, so this one we can cancel them, it goes missing. So now we do for x squared. Now we solve for the world of x squared. 52 minus 104 x squared, the world of x squared. So what I'll get is minus 52 lah. Minus 52 x squared. Use your calculator. 52 minus 104 is minus 52 x squared. Then at last you have a 48x here plus 48x divided with 16x power 4. Okay, you can further simplify because the top you can factorize an x out. Minus 52x plus 48. Okay, basically I divide this term with x, I divide this term with x. I get this thing. I divide it with 16x to the power of 4. Okay, and this is multiplying, so I can solve for x. See, this is x, I can cancel. This x power of 1, I cancel, so this one I take 1 away also, so I left with 3. So I left with minus 2x plus 48 divided with 16x power of 3. I do not know whether I made any careless mistake or not, but this is the way to solve it. All right. This is the way to solve it, basically. All right. For number 7, is the same thing. When you see 2 families of x together, what is the method to do it, right? When you want to differentiate it, what you want to do it is you copy the bottom first. Okay, don't forget, copy the bottom first. 2x minus 1 cube, copy it. Then you differentiate the top. How do you differentiate the top? This is a power chain rule. If you're not sure, refer to my previous video. How do you do the power chain rule? You bring a 5 down for multiplication. Then you copy everything. Power minus 1. Then you times the differentiation inside the bracket here, which is 3. Okay. Then I minus. Now, just now I copy the bottom, differentiated the top, right? Now I do the opposite. I copy the top. 3x plus 2 power of 5. Then I differentiate the bottom. Same thing when I differentiate the bottom, what I do is I bring the power in front for. I bring the power in front. There are 3 things I do. I bring the power in front. Then I copy this exactly same. Then the second thing I do is I minus the power with 1. Don't forget. Then I times the differentiation inside this bracket, which is 2. Okay, why is it 2? All these things you're not sure is because I've taught before already in the previous video. So please go and watch it up. Divided with, don't forget the last step, you got to divide with the bottom squared. Basically everything squared. 2x minus 1 cubed in the bracket squared. Okay. So what I get is Just roughly solve for the top. So this 3, 5, I'll multiply them together, becomes 15. Then I copy everything, 2x minus 1 cubed, 3x plus 2 to the power of 4, because 5 minus 1 gives me 4 now, minus what numbers I have. I always look for the numbers first, because numbers will stay in front. 3 times 2 gives me 6. So 6 will stay in front. Then I copy the rest. 3x plus 2 to the power of 5, 2x minus 1 to the power of 2. Okay, you don't have to expand, just leave it like this. Divided with this power of this square must times inside. Okay, there's only one thing to times inside, which is this thing's power. Okay, there's only one thing inside. Okay, which is this thing, power of 3. So you times with this power. There's nothing else to times. You don't say you times this one, then you times this one, because this one belongs to this power. You understand? This whole bracket belongs to power of 3. So if you want to square it, you just times the power here. Neighboring powers, you times the power. Remember, in this chapter, I've taught you neighboring powers, you just times it. So you might want to ask me, then why this one? Why this 4x squared? This 4x squared, why 4 you need to square, x squared also you need to square? Because you must understand, these two are two different things. 4 and x squared are separated by times. So this square must go to the 4, square must go to the x squared also. But for this one, right, there's only one, there's a 6 here. There is only one thing inside, one thing with the power. It's something like x power of 3 squared. There's only one thing. Because I told you anything in a bracket has priority. You can treat it as only one thing. Anything in a bracket, you can treat it as like a power of 3 squared. So it's straight away this thing to the power of 6. You understand me? Okay, but you can further do it. It's a trick in quotient rule. Normally, when you reach this stage, right, try to see whether you have same thing to cancel or not. Can you cancel or not? Can you cancel anything or not? You see, you have 2x minus 1 power of 3 here, 2x minus 1 power of 2 here, 2x minus 1 power of 6 here. It's something to say you have a cubed minus a squared over a. Can you cancel? You can. Basically, when it's plus or minus on top, you can actually cancel. But how you do it is I teach you. First, what you do is this power of 1, right? So this one, when you cancel, this one you take 1 away, becomes 2. This one you take 1 away, becomes 1. You have to take away from both sides. Okay, you cannot only take away from this one and not this one. You have to take away from both sides. So what you do for this one, right, is equals to, I write it down here. So I write 15. Okay, so what's the smallest power you can take out? The smallest power is 2, okay, power of 2. Because the maximum I can take out is 2 only. Because this one only allows me to take out 2. If I take out more than 2, it will go away. It will not give me something nice. So the maximum I take out is 2. Because this power 2, power 2, power 3, and power 6 take out the smallest power, which is 2. Okay, so what I do is this one I take out 2. I'm left with 1 of it only. 2x minus 1, power of 1. Why? Because I take out 2 of them. Okay, this is what you can do. Then I copy back. Plus 2 to the power of 4. Then minus 6. You didn't do anything to 3x plus 2, right? We made 5. Then this 2x minus 1, 2, right? I take out 2. I'm left with power of 0. Correct? Power of 0 doesn't give you 0. It's not 0. No. It gives you 1 because it's power of 0. Anything to the power of 0 gives you 1. Refer back to my indices chapter if you're not sure. Okay, divided with what? Divided with, because I said, right, these 3 things you have to take out with power of 2. So 2x minus 1 power of 6, I take out power of 2, I'm left with power of 4. Okay, don't forget. 2x minus 1 to the power of 4. So actually you have done it. This is your final answer. This one you don't have to highlight at the back. Basically what I've done is I've cut out some 2x minus 1. Because this one has 2x minus 1, this one has 2x minus 1, and the bottom also has 2x minus 1. So what I can do is actually you can actually cut off. But you must make sure, because you can treat this as one world, and you can treat it as one world. You must make sure that everything, these 2 worlds have 2x minus 1 squared. This one got or not got. This one got or not got. Then you divide, only you can do it. If on the left got, but here there's no 2x minus 1, you cannot cut like this, okay? You cannot cut just with this. Whenever you want to cut, you must cut with this and you must cut with this also. Basically, this. Okay, what I mean is something like this. When you have A plus B over A, right, it's not equals to 1 plus B because you cut. No. Whenever it's separated by plus, right, remember carefully, when it's separated by plus, what you need to do is you must make sure that this term has A, this term also has A. So it's something like A plus AB divided by A, and then you can cut A, and A, left with 1 plus B. Very good, can. This one, you cannot do anything. This one, the most you can do is you separate them. Become A over A, become A over A plus B over A, which is equals to 1 plus B over A. Okay, but when you have times A times B over A, times, let's just say times, you can cut one only. Cut one only, left with B. Can. Good, correct. Okay, what if you have A? Yeah, it's like this lah. Basically, you have to know these 3 different scenarios. These 3 different scenarios. Write it down. I'm a bit tired already. That's why I'm speaking a bit blurry already now. All right. So I will do number 4 now. How to do number 4? As I said, always when you see square root, don't leave it as square root. Try to change it to power. How to change it to power? How to change it to power? I teach you how to see. What is the power next to x is 1. What is the root of x? 3. So this one you can change it to x to the power of power root. This one is power. This is root. This one I taught you in this chapter again. So please refer back there. I don't want to keep repeating. X to the power 1 over 3 divided with x minus 3. It's the same thing, okay? So now, top has x, bottom has x. So I can use quotient rule. So what is the formula for quotient rule? F prime x is equals to fix the bottom, which is copy the bottom, x minus 3, differentiate the top. When I differentiate the top, how do I differentiate x to the power 1 over 3? Use power rule. Okay, power rule. Power rule basically means there are 2 things I do. I bring the 1 over 3 in front 2 times, 1 over 3 x, then copy back. Then the power I minus 1. This is power rule. Okay, so what I did is I copied the bottom, I copied the bottom, I differentiate the top, minus, now I copy the top, I write in terms of x to the power of 1 over 3 because the top is this one. I copy the top, then I differentiate the bottom. When I differentiate x minus 3, it's just 1. Why? Because you differentiate x just gives you 1 because the number in front of x is 1. And I told you, when you see x to the power of 1, when you just see x, basically x only, no square, no cube. When you see x only, when you differentiate it, you just see the number in front of the x. If it is 1, it's just 1. And negative 3, you differentiate, you get 0. So I'm not writing it. Okay. So what I've done, I repeat again. I copied the bottom, I differentiate the top. You see now x minus 3, I copied. Then I differentiate the top. Power rule, using power rule, I differentiate the top. Then I minus, don't forget quotient rule, you need to minus. Product rule, you plus. Okay? Minus. I copy the top now. Now I copy the top. Just now I copy bottom, now I copy the top, which is x to the power of 1 over 3. Then I differentiate the bottom, which is this thing, and I get 1. Then don't forget, quotient rule, you've got one last thing to do. You've got to divide with x minus 3 squared. Okay? I find this as a better way to understand now. Not to say to understand. You want to stick with formulas, so can, you know? You can say, oh, v minus b du dx minus u dv dx over v squared. You can also if you want to. But usually to me, I'm used to this method. Bottom, fixed bottom, you copy bottom, differentiate top, minus, copy top, differentiate bottom, divided with bottom squared. That is what I'm used to do. Okay, so I hope that you can follow that. If you don't want, you want to use formulas, also can. It's up to you, totally up to you. You still get the same answer, okay? So I try to simplify it. I want to put a number in front, so I have 1 over 3 in front, x minus 3, and then x to the power of 1 over 3 minus 1 gives me minus 2 over 3. Then minus 1 times x power 1 over 3 gives me x power 1 over 3, same thing, divided with x minus 3 squared. Is there anything you can simplify? Can you cut these two? Can you cut this one and then this one become 1? Cannot. Why? Because as I mentioned already, as I've mentioned many times, if it is separated by plus or minus, remember plus or minus, plus or minus, plus or minus, plus or minus, plus or minus. When it's separated by plus or minus, this term must have, if you want to cut something, right? If you want to cut, for example, x minus 3, this one must have x minus 3, this one must also have x minus 3. But this term does not have x minus 3, so you cannot cut like this. You understand? You cannot cut like this. You must, if you want to cut, you must cut from this term, you must cut from this term also. Okay, but the right hand side don't have x minus 3, so don't cut anything, just leave it like this. Okay, unless it's times. Times, then you can cut. Okay, you can cut this one and cut this one becomes power 1. But now cannot. Why? Because it's minus. Don't forget, a lot of people make that kind of mistake. If I were you, I would already done if I do not know now. All right. And I'm speaking a bit softer and softer already. Okay, we move on to question G. Okay, I'll move on to question G. So how do you do question G now? Same thing, something divided by something. I change it. I don't want to see the square root. I try to change it to index form 3x. I try to change it to power of something. So in a bracket, don't forget a bracket, 4x squared minus 3 in a bracket, power of half. So I've changed it already. So now I know it's going to be quotient rule because it's x, family of x divided with family of x. Top has x, bottom has x. So I use quotient rule. So how do I use quotient rule is basically g prime x. You see, whatever they give you, if they give you fx, f prime x. If they give you gx, give you g prime x. If they give you y, put dy dx. Okay, so it's equals to 1. So as I said, start with copy the bottom, which is 4x squared minus 3 to the power of half, times with the differentiation of the top. Differentiation of top will give me power is. Power rule, you should get 6x. Okay, I don't want to teach you how already. You try to learn yourself from what I've taught you in previous videos. 6x minus, I'll tell you what rule to use, but I won't go through the steps with you, okay? Minus, now you copy the top. Just now you copy the bottom and differentiate the top, right? Now you copy the top, 3x squared, and you differentiate the bottom. Don't forget, it's minus, okay? Then you differentiate the bottom. How do you differentiate the bottom? This one is to use the what rule? How do you differentiate this thing, this chunk of thing? How do you differentiate 4x squared minus 3 power of half? How do you differentiate it? Don't forget, when you have in a bracket, squared, in a bracket to the power of something, use power chain rule. I call it power chain rule. Okay, power chain rule. How do you use power chain rule? When you differentiate it, basically what you do is 3 things you do. Power bring in front, then copy everything. Power, you minus 1, this is the second thing you do. You have done the first thing times half in front, then power minus 1, you do second thing already. Then the third thing you need to do is you got to times the differentiation of inside the bracket. Okay, times the differentiation of inside the bracket. So you know that negative 3 will give me 0, so I don't have to care for negative 3. When you differentiate 4x squared, what will it give you? Using power rule, it will give you 8x. Okay, power rule do 2 things. As I said, don't forget 2 bring in front for times, then the power minus 1. So that's why I get 8x. Okay, so what I've done, as I repeat, copy the bottom, differentiate the top, copy the top, differentiate the bottom. Okay, top is this one, bottom is this one. Then I divided with this thing squared. This thing squared is 4x squared minus 3 to the power of half in a bracket squared. Okay, so basically I just simplify everything. 6x, I like to put it in front, and then 4x squared minus 3 to the power of half minus, okay, numbers, I just solve for the numbers first. Numbers. Half times 8 times 3 gives me 12. 12. Then I put x squared first. Then only I put this last bracket. 4x squared minus 3. Half minus 1 gives me power of negative half. Half minus 1 gives me negative half. Then I divide with what? I divide with, okay, neighboring powers, you can multiply the powers. In indices chapter, I've taught you already. Neighboring powers, you can multiply the powers. This one I've taught you in what video? The video under Form 4 chapter 4. Form 4 chapter 4. Form 4 chapter 4.1. Yeah, 4.1, I think, law of indices. Correct, 4.1. Okay, so you just multiply the powers, you get 1. So you just get 4x squared minus 3 to the power of 1. Okay? That's all you do, because this is in a bracket, so you just need to multiply these 2 powers together. That's it. All right, so this is the final answer here. So basically, remember the method. I go through for product rule again. Product rule, don't forget product rule. Okay. Wait. I give you a summary. I'll give you a summary on the next page. For product rule, you write down if you want to. what you do is dy dx. If you want to use formula, if you use formula is u dv dx plus v du dx. What is u and what is v? When you have y equals to u times v, basically a family of x, first family of x and second family of x. Or you want to use my method is basically dy dx is basically copy the first times differentiate the second, then it's plus, don't forget it's plus, then you copy the second, differentiate the first. Okay, basically you just change the location. First becomes second, second becomes first. Okay, that is product rule. What about quotient rule? Quotient I write in red. Quotient rule is basically, if you want to use formula, when you have y equals to u divided by v, basically a family divided with family, basically top is x, bottom also has x, you're dividing them. The formula is dy dx is equals to, you copy bottom, differentiate the top, minus copy the top, differentiate the bottom, divided with b squared. Or, in other words, if you want to use my method, not my method, basically, it's not the formula method, it's just basically another way to memorize it, the formula. It's just basically differentiate, I put diff, differentiate second, must start with second first, for this one, differentiate second, don't forget, differentiate second. Hey, what rubbish am I talking? Sorry. Okay, first is you copy the second, copy second, then you times with differentiate the first. You see, copy the second first. I start with copying the second first. On top, for product rule, we copy the first one first. Okay, but this one, we have to copy the second first. Differentiate the first, then minus, don't forget it's a minus. Don't forget this is very important. Very, very important. Minus. Then now, what you do, just now you copy the second, now you copy the first. Okay, copy the first, times it, differentiate the second. Just now you differentiate first, now you differentiate second. Okay, what do I mean by second is when you have, I shouldn't use first and second. I should use top and bottom. Okay, so I'll use top and bottom instead. I'll use top and bottom instead. Because top and bottom is easier to understand because when in quotient you have something divided with something. So you know what is top, what is bottom. Copy bottom, differentiate top, minus copy top, differentiate bottom. Okay, divided with bottom, the whole thing squared. This is basically the whole thing. The whole thing I want you to understand. Don't forget. Okay, and the minus, don't forget the minus. This plus, this minus. Very ugly. Let me use other colors. Let me use yellow. This plus, this minus. Don't ever forget it, okay? This is all the thing you need to know. Just try to get used to the formula. So that is N for quotient rule. Yeah. Let's have a question rule. The rest of the questions you can try yourself. For question number 5, right? Oh, this is supposed to be X. I made a mistake. For question number 5, what you can do is when you have a square root on top, square root on the bottom, you can actually combine them into one square root. Okay, I leave it for you to do. Okay, you can change it like this. Then what you do now is when you see things like this, when you see multiple terms and one term on the bottom, you can actually separate them. How do I separate them? I will get x cubed over x minus x squared over x minus 1 over x. I separate them, which will give me x cubed minus x power 3 power 1. So I take away minus the power, gives me x squared left. This one 2, this one power 1, same base, I minus the power, gives me x. As I said, why I'm going so fast is because I've taught this before many times in indices chapter. So make sure you're good in your indices before you come to this chapter. Minus 1 over x. Now you can actually, what you do is actually, there are many methods to do this question actually. There are many methods. You can actually make it into the power of half, then use the what rule? Use what rule? use the power chain rule. 3 steps. The 3 steps power chain rule. Okay, don't forget you can use the power chain rule here. Or if you don't want to do all this mess, right, what you can do is actually, right, I tell you what you can actually do, right. What you can actually do is basically straight away use quotient rule. Basically, the top is x, bottom is x. So top I change it to x cubed minus x squared minus 1 to the power of half. Bottom I change it to x to the power of half. Why is it half? Because square root can change it to the power of half. Okay, you must memorize it. So I can actually change it to this. Okay, I just convert it to half, and then basically I use quotient rule. I fix the bottom, differentiate the top, minus, fix the top, differentiate the bottom, divided with this thing squared, bottom squared. As I say, if you're not sure, refer to the formula here, okay? The formula I've written here already. Okay, I would focus on this one more. Similarly, I'll focus on this one more. Okay. Yeah. Or if you want to use formula also can lah. If you all still don't understand and you all insist that, oh, I want to use formula, but Brian is not teaching the formula. So what you all can do is you all can comment in the comment section below, and I'll try, if there's enough people who ask for the formula, then I'll teach you the formula. Basically, it's just the same thing lah. Basically, but I just change it to teaching it formula. Basically. But I don't think you won't understand. If you go through all the questions that I've taught you here, you should understand. You should understand how does quotient rule work. Quotient rule is for division, okay? Product rule is for multiplication of families of x. Don't ever forget that. All right, so with that, actually, I'm done with quotient rule. As I said, practice all the questions, okay? Practice your school questions, practice almost every question, and you must make habit to yourself. When you see a new question that you do not know how to do right, don't feel frustrated, don't feel demotivated. Feel that, oh yes, finally I'm including a new type of question into my question bank. And that's a good thing. Instead of maybe 127 questions in my question bank now, I have 128 questions in my question bank now. So that next time when I see, I have more question bank to search for, you know. You get what I mean? So I want you to have that habit. Don't be scared of questions. When you see hard questions, do not know what to do, find a solution, ask your teachers, ask me also can, and then learn from them. Once you have learned from them, make sure you don't ever forget them. Understand them thoroughly and don't ever forget them. Okay, so I'm done with product rule, quotient rule, and the first power rule. Okay, so let me summarize what I've done so far. First is the power rule. Power is the most basic one, which you use every time, power rule. Then I've covered the power chain rule also. Power chain rule is like a brother of power rule. Power chain rule, the only difference about power chain rule is that you have a bracket and to the power of something. And then outside of the bracket can have x. Because when outside of the bracket has x, it is actually your third rule, which is product rule. Okay, I've covered product rule as well. And then fourth is your quotient rule. So what you need to remember for each of the rule is, first rule is product rule. You have 2 things to do. Okay, maybe I summarize one for you. Maybe I summarize one nicely for you. Oh, I've done with product rule and quotient rule. So now I'm doing for power rule. Power rule, there are 2 things to do, okay? 2 things to do. Okay, you must know yourself what are the 2 things. If you do not know, please watch back my previous videos or previous questions on what I did. And power chain rule, I just call it this way. It's not necessarily called this way in your school. Power chain rule, what I do is actually, there are 3 things to do. Okay, 1, 2, 3. Okay, actually, I can tell you the power. What you do is bring the power down for multiplication. Please bring the power down for multiplication, and then the power must minus 1. Okay, this one is same thing. Bring power down for multiplication, then power minus 1. Then lastly, you got to multiply with the differentiation of the bracket inside. Okay, so if you are just jumping the video to this part and listening to this part, right, you won't get anything. Believe me, you won't get anything. What is inside this thing? My idea of the video is, right, I expect you to follow along so that you get it what I'm explaining in every step. If you follow along me, right, I would say that you would straight away know what I'm saying here already. I think, I assume, I hope. Pray that you know lah. Okay, so with that said, actually, I'm done with the whole part of product rule and quotient rule already. We are left with one chain rule. We're left with one chain rule. Chain rule not very famous, but chain rule can ask also. You need chain rule for one of the chapters later, which is one of the subtopics later in the same chapter, which is rate of change. Okay, so I'm left with chain rule. I'm doing it in the next video. Then I will do second derivative. Second derivative is in part 4. Okay, I will do part 5 first, chain rule, in the next video. Then in the next video, I will do second derivative. Okay, then I'll move on to, and then we are done with chapter 2.2. Means we are done with chapter 2.1, chapter 2.2, whole thing really. Then we move on to chapter 2.3, which is tangents and normals. We'll do a lot of tangents and normal questions. And then after tangent and normals, we move to 2.4, which is maximum and minimum, right? Then later on only we'll move on, continue to rate of change, small change, approximate. Then we're done with the whole chapter. Okay, so roughly they are around 2. Let me see how many are. This 2.4, 2.3, right? I don't follow your syllabus, okay? But I'm teaching you everything in your syllabus. But I just arrange it in the way I want to teach you. You understand? So it's easier for me. But I'm teaching you everything. Don't worry. Okay, so 2.1, I go through this. 2.1 is roughly almost everything about the basics, limits, first principle, and understanding. 2.2 is what we're doing right now, is all the rules, product rules, all the differentiation techniques, product rules, quotient rule, power chain rule, and whatever it is. Okay, and then the 2.3 would be on gradient of tangent. Gradient of tangent, okay, we will be doing equation of tangent, gradient of tangent, then equation of tangent. Then how we find gradient of normal. What is normal? I'll teach you later on what is gradient of normal, and then how we find the equation of normal. That is all about 2.3. And then 2.4, how we apply a differentiation to find maximum values, maximum and minimum values. For simple graphs for you, maximum and minimum values. You can find one for quadratic graph. You know what's the maximum value, you can use differentiation. Or actually, if you learn your syllabus well, you can actually use completing the square, which you learn in earlier chapters, in quadratic chapters, completing the square, right? So at last, after 2.4, you probably have 2.5 on, probably, I haven't designed it yet, 2.5 probably on rate of change. You learn rate of change after maximum minimum, rate of change. Then after 2.5, you go to 2.6, you learn all the small change, approximation, then you're done with the whole chapter. All right, so around 2.6, I give you a run through of the chapters. So next video, we do chain rule. We are done with this. Don't forget to practice and ask questions, ask as many questions as possible. Ask me, ask your teachers, ask your tuition teachers, or whoever it is. All right. So we'll meet each other in the next video. Until then, please stay safe. All right. COVID is not nice. It's not friendly now. All right. It's restricting me at home now, which, all right. Anyways, stay safe until the next video. I believe you can study well. All right. See you in the next video.